It's awesome to see actually this on-device AI, what's going to happen over the next 2 to 3 years and 5 years and beyond, as more developers kind of tune in, start to pay attention, start to see like, oh, okay, so all these phones can do all this stuff. That's amazing.
Oh, yes, it's the Qualcomm podcast. I'm PJ. Thanks for listening. Qualcomm makes some of the best technology on the planet. I'm going to bring you interviews with the experts and the inventors here so you can understand how the technology works and find out what's coming next. Welcome to the Qualcomm podcast. This is a big day for the Qualcomm podcast. We've been talking about it for a while that we always wanted to bring in an external guest. And today we're lucky to have two from Google to talk about AI with us. Chung, who's the Director of Product Management for Google Lens, and Brahim Elbouchikhi, Director of Product Management for Android AI and camera products. We're also joined by Qualcomm's AI Product Manager, Gary, and Product Marketing Lead, Kristen. The last time we did an AI episode, it was probably like a year ago. Honestly, in the past year, everything's been just moving so rapidly that I think we should just take a small step and just kind of remind the audience what's going on in AI. And where is it? It was in the cloud, now it's on device. What is AI? Gary, can you just give me, like, when we talk about AI these days, the biggest revolution, am I wrong about this? Is this correct? The big revolution that's going on right now are neural nets.
Oh yeah, I think that is a class of algorithm that's solving for problems that have already existed, but also creating new opportunities. If you pull back a bit, a lot of what we see in what had been previously like classic computer vision or natural language processing, a lot of the work and a lot of the software effort had been in very specific purpose-built scripting to solve for a very finite problem, detect a cat or a face. Mm-hmm. But with copious amounts of data, incredible compute power, and algorithms that have been sitting latent since the 80s that really have the ability to deal with tons of data and more breadth and depth, these same use cases with these new algorithms, the AI, you classify them any way you want. AI is really a broad term, but let's say convolutional neural networks, mm-hmm. LSTMs, RNNs, the neural network class, developer flexibility, higher degree of accuracy, higher degree of performance. So the immersion that a consumer gets from the user experiences or the enterprise when they're trying to leverage this, the much higher value. Okay. Our place in the ecosystem, though, is the on-device component. So much of this has been relegated to the cloud for years, and I think everybody in this room has dealt with this in one way, shape, or form over the past 4 years, is that it's no longer a cloud problem. It's also an on-device problem, because the device you have in your hand should not be orphaned and left with no utility if it doesn't have a connection. Right. There's enough processing power to do that today. So that's where this conversation is, and this is kind of exemplary of the relationship that we have with Google, with on-device specifically, but the Google Lens use case and leveraging in an API. This is all like coming into its own. Like, this is all here, that's all real, that's all now.
Okay, cool. So just for me to summarize, when I tell my friends outside of work what's going on, it's transitioning, AI is transitioning onto the device, and like the benefits of that is, first, you don't need an internet connection. So you can, if you happen to not have an internet connection, your AI will still work, it will still perform the task. I would assume it's also perhaps more secure, because all the data stays on the device. Yep. And it's probably could arguably be faster because it's on your device right there, not going up to the cloud. Exactly. Got it. Okay. And I just want to throw this out there. When we talk about neural nets, I kind of think about it in two parts. There's the training of the neural net, and that is where, to your point, massive amounts of data are put into this thing. It's fed to the neural net, trains it, and then it spits out this tiny file size that's the neural net, and that's the thing that runs on device.
Yeah, tiny is relative. Yeah. And I think in the context of this conversation, you'll hear that the way in which we work together, and really the Google folks drove kind of the optimization of that. So if you have a full precision network that you trained, it does have to be optimized and compressed to some degree to run on a target that's constrained. But I would be very careful to define tiny.
Right.
You could take the exact same network that you're running in the cloud, run it on a device. It really depends on the use case.
Well, I think tiny because one of the things that helped me understand this, not trying to skip ahead here, but I'm a Pixel user. The Nexus 4 used to have sound recognition. You hit a button, it can recognize a song, it would send that audio file up to the cloud, it would recognize it. All of that now is done via AI on device.
That's right.
Yep.
Yeah.
That is mind-blowing. So the reason why I say it's tiny, apparently it's a neural net that's on your device. It's always listening for music, and it can identify the music without an interconnect connection, but it was trained using a catalog of about 70,000 songs. And let's assume each song is about like 5 megabytes. That's massive amount of data, and the end product, the neural net, apparently is just like 20 megs or lower.
Yep.
Yeah. Sounds about right.
Yes. I mean, we do techniques like frequency domain analysis, right? So that further compresses what we can do, but it is pretty amazing that we can achieve all of that, on device, ambiently, right? Through
and low power.
That's right.
So with the help of Snapdragon hardware, I believe that's placed, at the most optimum part of our chip for low power, which would likely be the DSP in this place.
That is one of the targets, probably the most optimal at the moment.
Cool. So I mean that's why I'm
For
like
that use case.
It's so hard to it's just so hard to wrap my brain around how a catalog of 70,000 songs could be compressed into a little neural net. But that's the amazingness of what's going on.
Sometimes they would have this multi-stage process where there's like a course classifier that just says, I think there's music playing. And that's the first step of the process, which then kicks in a much beefier process or model that actually then determines what song it is. That way the power is actually we're not constantly looking at, is this one of those 70,000 songs if you're just hearing us talk. It just looks for a frequency that sounds like music and it says, okay, let me now call the bigger model, to figure out which song specifically it is. And many of these happen this way, even Lens.
Yeah, and we have that in some of our own, like SVA. There's stage 1 where you detect, and then stage 2 where it's more the recognition side.
Yeah. So I guess let's jump into what we think is one of the hero applications, Google Lens.
Yep.
Eddie, this is your domain. Again, when we think AI, I think Google Lens. I remember when you guys first announced this was like just mind-blowing. Am I wrong to characterize it as like Google? You can now Google anything you're looking at.
Yeah, I mean, let me kind of back up and add on to what Gary was saying is, computer vision powers Google Lens, obviously. But
do you mind defining computer vision?
Yeah, computer vision is basically processing an image and then bringing understanding to what that image represents. Right? Is it a cat? Is it a person? Is it a product? Shirt? That kind of thing. So the camera is
not just like capturing the image; it's also trying to understand
what
the image is.
That's right. So that's our visual search product, Google Lens, and I want to say that computer vision. Through deep learning and AI has advanced significantly from, I would say, largely pattern matching algorithms, right? So it's like just matching patterns to something that is actually very robust, can take a wide range of inputs and environments, and then bring understanding to what it's seeing. So, neural nets roughly models your brain, right? So you train your brain to understand what a cat looks like, a person looks like, a product looks like, that type of thing. And once you feed a massive amount of data into this neural network, it can predict things, right?
So you're literally feeding it, like if you're trying to get it to recognize cats, it's just picture after picture of a cat.
That's right. But, I think the key difference is this is not, pattern matching algorithms. An example is like, we learn to read, and we don't learn to read by just, exactly pattern matching fonts, right? We learn the shape of the letter, right? So that even if there's a completely new font that you've never seen before, you can still read it, right? So deep learning has advanced computer vision to a state where we can predict, new inputs and still get the right answer. So it's dramatically changed the robustness of products like this. Now, the second advancement is now being able to move a lot of this processing on device. And, similar to the example that you mentioned about, detecting music ambiently, this unlocks a lot of new capabilities. I would say just purely from a product perspective, reduce latency. So right now, you take a picture of something and then you send it to Google's cloud, and then we process it and we tell you what it is. It's a cat, it's a labradoodle, whatever the case may be. The round trip takes, I don't know, hundreds of milliseconds, maybe over a second, few seconds. Imagine if you could just point your camera at something and then just instantly, in like, I don't know, 10 milliseconds, we give you the response back. I mean, it's that kind of product experience that is enabled by on-device AI. I'll also say, from a quality perspective, things improve significantly. Right now, what we do is the user takes an image. We actually have to compress the image, right, and then send it to the cloud, just purely for bandwidth reasons.
Okay.
And that results in a loss of fidelity. For things like recognizing text, that matters a lot, right?
Because then it becomes like blurry and hazy.
Exactly, that's right.
So now, you want as big of an image as you can.
When it's on device, there's no need to compress. We can just look at the full frame with the full detail.
That's interesting.
So quality is improved significantly as well. Also, this is actually kind of misunderstood, but power is actually reduced as well. It's actually more efficient to process these images on device than to send it to the cloud with the network overhead and then consolidating this with compute resources in the cloud. So from a macro perspective, power is also reduced. So there are many, many benefits to on-device. And I'll say the last one, which I think is extremely important, is that, with a camera, this could be sensitive information, right, or sensitive to the user.
Yeah.
So doing more of the processing on device also improves privacy, right? Everything stays on the device. We're just processing the image and then, spitting out, like a mathematical representation of the image and then telling you what it is. So it has a ton of benefits, and I'm super excited, of what's ahead here, partnering with Qualcomm and, the advancements in the hardware that they're pioneering.
The on-device part of it is just so much more delightful as an end user, right? Without all the tech that you guys are talking about, just to have things respond quickly and be able to take an action from that, as an end user, is just a far more delightful experience.
That's right, yeah.
The low power consumption, this is where Qualcomm, we're just obsessed with this. This is our territory where we just want to try and make our hardware as fast as possible, but as low power as possible. And I believe this is where we come in and work with you guys and try and find for your algorithms the best place on our processor on Snapdragon to execute those algorithms so that they're piping fast, but really just sip the battery, very low power.
I mean, one of the top reasons why somebody buys a phone is the promise of more days of use, and I think the top reason why they don't use a phone anymore is because the battery, right? That is a key pain point. So
Totally.
It has been a big focus.
But Lens. So what is Google Lens? I don't think we've defined it.
Yeah. We're in short giving, Google eyes, right? So for a long time, you typed into a search box and, Google provided you answers. Assistant gives you the ability to talk to Google now, and Google Lens now gives Google the ability to see and help you with what you're doing. So we're focused on two things. One is, oftentimes words just fail us. It's like, that shirt. How do you describe that shirt? Sometimes you just can't.
More often with me, but go on.
Yeah, that's right. Or those shoes, or like those pants. It's hard to describe things in words. So now it's just like, hey, just show Google, right? And then we can give you the right answers. The other thing, another example there might be like a flower or like a tree or an animal. Sometimes it's really hard to describe these things. So now it's just show Google, right? The other thing we're trying to do is really help with, I would just say, making kind of the mundane quicker. And what I mean by that is like, text. Text is all around us. Mm-hmm. And sometimes you just want to, you see a flyer, you want to call that phone number. Yeah. Right now you have to like take a picture and maybe write it down by hand. Right now, it's like, well, we can just recognize that text and then have you call that phone number in an instant, or the URL or the address, things like that. Or if you're traveling, translate that street sign, right? So I would say, vision gives us a lot more capabilities to help the user, right? I think our cortex is like dedicated, 30% of the cortex is dedicated to, just vision purely, right? So we're adding a brand new capability to Google, and that unlocks a ton of new use cases.
Huh. One of the new use cases that I saw when you had first debuted Google Lens that just blew my mind away was firing up Google Lens and showing it a Wi-Fi network name and password, and it observed it and then just put the phone on the network. I was like for 3 days I was walking around in silence, just mind blown by that.
It's funny because when we show just these mundane things like text, people are blown away, right? And I think it's easy because we're so knee deep in this to lose sight of this is kind of magical, right? Like it's a camera that can read, basically, right?
Well, I was just at a restaurant yesterday.
Yeah.
And they were doing a fundraiser on the outside, and they were handing people flyers to walk in so that they could use the code.
Yeah.
And I actually said to them, can I just take a picture of it? And well, no, it's not going to really. How are you going to use the code? You need to. So I mean, just think of that from like your kids and your fundraising and your all sorts of things where you can get rid of paper and you can just action something that you've taken a picture of.
Yeah,
it's pretty cool.
At the last Google I/O when we showed a bunch of demos. Actually, the strongest reaction was just copying and pasting text from a flyer, right? There's a lot of like oohs and ahs on that specific thing.
I totally agree with you. I think, honestly, I feel like 50% of my pictures now are just not like me and my friends. They're just like things that I need to remember or like stuff, to your point,
That's
I need to call and everything.
And actually, you'll be surprised. Like, just based on our data, it's, I think, over 10% of photos taken that at least, on Android phones are just purely functional images, right? So it's like receipts, flyers, these things, right? And that's actually why we're focused a lot on just pure text recognition and translation and things like that.
Yeah, a camera's it's like a utility.
It's a utility, yeah. It's not just like, hey, capture memory with your family. It's like, take a picture of that parking ticket or, this receipt or this document. So.
I mean, AI is also making, I also work on our camera team and the Pixel camera.
No.
AI, and AI is actually making even the photography part way better too.
I saw
the utilitarian bit plus the photography bit. I think what's cool also is that I feel this is another one of those cases where like a technology gets to a certain state and then it kind of triggers new things. So like cameras, users love them for like selfies and other things like that. And that's how we got really amazing camera modules in all these phones. And now we can actually do all sorts of things beyond just the selfie stuff. That actually is super cool. We can see utilitarian use cases. And it is super magical when like the Pixel camera just pointed at something and it detects the link or it detects like all the other things that this team is working on just on the fly in real time with low power. Super fast. You can then act on it, and it really is like a new superpower. It feels like a new superpower.
Yeah, totally.
We've moved beyond vanity and the camera to utility.
Yeah, full circle. Full circle. Like we're back to utility again.
At Qualcomm, I mean, most of our time we're talking about getting really under the hood. So I kind of want to get under the hood and talk more about the Android NN API. First thing is, let's define for our users what an API is.
Oh, what an API is. It's basically an interface between two pieces of software. It's the way software talks to other software. The goal of NN, right? So essentially, whenever a new ecosystem emerges...
NN, neural net.
Neural networks, API.
Yeah, NN API.
Yeah, NN API.
Okay.
The goal of it is whenever a new ecosystem emerges, there's a risk of fragmentation and confusion. And because there's many people trying different things and different ways of doing things, and there's not mass adoption, there's not a standard way of doing things. And you can think of this pre-graphics and, this has happened many, many times. And so with NN, what we try to do is essentially create a standard interface between the software layer and the hardware layer. So it's literally like a hardware abstraction layer. Okay. And what that means is that me as a developer, if I'm building an app, I can know that it will work on any device, in this case built by Qualcomm that supports these drivers. And that over time, I don't have to worry about having a bunch of if statements that say, if this device do this, if this other device, you can't run this model, you can't run this because this op is missing. We want to just standardize and make sure that as a developer, I can build a great experience and know that it will work everywhere, that it will run everywhere. And that's the mission. At Google, we love open ecosystems. We love when we think innovation is bottom up. We think that thousands and tens of thousands of developers out there are always going to probably over time out-innovate us and think about more ideas. And it's awesome to see actually this on-device AI, what's going to happen over the next 2 to 3 years and 5 years and beyond as more developers kind of tune in, start to pay attention, start to see like, oh, okay, so all these phones can do all this stuff. That's amazing. What's cool about Lens is that it's a hero. It motivates developers. It inspires developers to be like, oh my God, like look what this thing can do on device, right? It's also on-device is free, which is a really awesome side thing we can talk about later, unlike a lot of cloud services. So we need these sorts of inspirations, but we also, like Lens, but we also need to simplify the experience for a developer. They don't have to think about what hardware am I on, what device is this, can it do this or not. So these are the two ingredients that we think we put together on Android on a regular basis and try to then kind of spur innovation and get developers to think about awesome new experiences. So it's super exciting. Working with Qualcomm has been like really, really productive. We worked through a lot of challenges initially, again, because we're in the V, like if you think of where we're at with so many other technologies that have been around for 10 years plus, we're here in like, just like the very beginning. And so we had to work through a lot of challenges and, missing operators that weren't supported by the Neural Networks API and then getting them supported in all sorts of ways and then working together to tune and iterate. And it's been fascinating to see how much better things have gotten since the first driver until the actual driver that we ended up with. I mean, like multiple X's. Yeah. Improvements in power, latency, precision, and working super closely and iterating fast. And so it's been a really fantastic experience. And I think what I'm excited about is, again, kind of having Lens be this exemplary example to developers who can then get inspired to do even more. So you're kind of seeing two flavors of Google in this podcast, by the way. There's the really amazing product where we own the entire experience, but there's also the platform aspect where we want to enable other people to do cool stuff.
Yeah, I see it as Lens is an amazing first-party Google app with AI, and the NN is here to help make third-party.
The ecosystem, right. Everybody else do it.
Yeah, and it has been... I think that to say that, in a new industry when we're all kind of learning and trying to feel our way through, you guys have been great guides for us because we know our domain, we know what makes, our hardware performant, the tooling, et cetera. But since this is all very fresh, the insights have been very good. I think the collective result is pretty much, it speaks for itself in many ways based on the description and if you've ever felt it and played with it yourself. So totally. It's been great.
Yeah, I saw when initially when the Android NN API was introduced, I believe it ran on our CPU. But I read on a blog post on your website, once Android P was released, you had included a driver so that it runs on our DSP.
We developed the drivers. So if you look at the NN API interface, as Brahim mentioned, the goal is to provide developers with a consistent platform so they don't have to worry about the underlying hardware, ours or somebody else's. They just know that the net that they've trained up to drive this user experience matches, the topology matches some accelerator under the hood, or what that can support. So anything to do with the drivers and the execution and processing of that net is still Qualcomm's burden, right? So whether it's CPU as a fallback or GPU, which gets 5x over the CPU, but the hexagon vector processor and then the tensor accelerator are getting exponentially greater performance and power savings. But all that work is ours. In fact, now I'll entertain your discussion about the construct of a neural network, right? So there are a number of math operations, the operators that make up a neural network. We have to do all the kernel writing and hand coding to ensure that each of those operators in a neural network is accelerated to the nth degree on each of our accelerators. And that's a lot of work. I mean, there's like literally hundreds of them to have to do for each core, for each precision of the network that we support. So we have, that's our responsibility. But the work that we've done with the NN API team on finding the right balance of, but there's a huge volume, what do we focus on first? And how do we make the NN API increase in its utility exponentially, even from one release of Android to the next? Again, we've learned a ton, but there's a lot of work that goes into making this happen.
Totally.
Yeah.
And that's also why we're more than just the CPU. We include all of this different cores inside of our platform. So we have all these different types of math libraries that we can run. These different
so we've done. I mean, you've heard this, but maybe the folks who are tuning in the first time is we don't look at AI as a one-size-fits-all problem, and I don't think Google does either. Right? There's different power and performance profiles. There's different environments that you're constrained with. There's concurrencies that you sometimes don't even know how to manage. Right? So you have to have enough flexibility, and if you anchor your development against a dedicated accelerator that is fixed in what it can do, and you do that, you make that design, you make that 18 months before it hits the market, there's a lot of utility that will just kind of slough off. Algorithms have moved so far forward that the dedicated accelerator can't handle. So you need to have a variety, and we've always preached the heterogeneous approach.
Right. Those are all the different cores.
Yes.
The heterogeneous.
Yes. So CPU, GPU,
DSP,
vector processing,
got an
and there's
ISP,
more going on
yeah.
that we're leveraging too, but these are the primary.
Right. Very cool. We have the Android NN API. I believe in version 1.1, we've helped further optimize where it's placed, where it's processed on the on Snapdragon. We moved it to the DSP for even more speed, lower power. And now I see you guys have just announced Android Q, the first beta. And the Android NN API is now in version 1.2.
Yep.
Is that correct?
Yep.
And is there any... I mean, is it just it's just even tighter and faster and lower power, or are there any other features that you'd like to point out?
Yeah, I mean, this was another awesome example of working with Qualcomm, because about a year ago, almost to the day, we all got together in a big room in Mountain View, and then we talked about the NN API, and we had a very frank conversation about what's missing and what's not.
Cool.
And Q is really the result of that. Is really actually, I would have probably called it a 2.0, but the team wanted to call it 1.2.
It's a big release.
We won't debate that. But it's actually
It's
a massive release. So,
huge.
for example, when I said the way we worked with Lense and Qualcomm with the P drivers, we had to do some kind of not hacks, but some things to make it work. All those things are now very much native with Q. So like the LSTM Q up is now native in Android, so you can just work without having to do anything special. Also, we optimized performance. The overhead with NAPI was a bit high at the time. We optimized that a lot. We also increased the number of operators supported, like these things that are the basic blocks of a model to about 80 from, I think, like 30 or so. Yeah. And the ones actually implemented.
The exact number.
I show it to, we use it for resource discussions internally, but yes, it's like.
And then the ones that are actually implemented.
Yes,
let's
exactly.
not talk about that. No.
That's exactly right.
So now we're at about 80. And so what that means, 80 means that you now, as a developer, don't again have to be like, oh, I'm using this op. It's not actually supported. I have to think about an alternative. You can now just basically build a model, and you're very, very likely that it will just work. And so we work across the industry, actually, internally within Google, with the Google Brain team, TensorFlow team, with all of our first-party partners to determine what are the most...
What's the Brain team?
Brain is like a research team that works on Google Brain.
Google Brain.
Wow.
Yeah.
That is...
It's the brain, yeah.
Yes.
So we worked with all these teams, and actually one of the hardest things about Q was to figure out what is that list of 80 ops. Because this industry is moving so fast, and there's actually disagreement even within Google about like, well, you should include this and this and that, and it's like, my use case needs this up, and no, that use case. We actually went to some of our friends in the Valley and others who actually work with them as well to see, hey, what matters to you, what ops matter to you, and so this was one of those fascinating. Like a tracker, like a matrix with like a bunch of rows, and being like, okay, who's asking for this? How important it is? How common is it? How generalizable is it? And then there's also multiple flavors of it, like an LSTM. There's many different flavors of it.
What's an LSTM?
You guys use it. So
long short-term memory. It's a type of network that has memory. So it's important for things like reading text where it matters what you saw before. Right.
Wow.
So it's like, in the stages of how we read, how we enable reading, a camera to read. There's first what we call a CNN, a convolutional network, which just detects, is there text here, right?
Okay.
And then there's an LSTM part of the network that actually reads each line of text and all the characters. And LSTMs are necessary because, again, what came before matters a lot more. So it's not just about, is there text here? It's like, is this a T? Okay, prior to that, then this is probably, this letter.
Interesting.
So in translation also it's cool where like gender of a certain subject or something, then you have to remember that when I say the in some sentence there, I'm talking about Paris, for example, or I'm talking about a woman versus a man. And so that way in translation, you're actually able to translate this stuff properly. So it has memory, it carries memory. Super cool.
That's interesting because I think those of us who aren't as knowledgeable about this stuff tend to think of software as very linear, that it kind of progresses forward and however it's being processed. But this seems like it's going back and moving forward and going back again and moving forward. And so the processing power of that seems like it could be great too, and you could potentially miss things. So that's pretty interesting.
Yeah, and to kind of add into what Brahim was talking about, this is a really fast evolving industry, right? So LSTM as a concept is general, but our researchers, they're like world-class researchers that have built models that can, read lines of text, and it required actually a specialized version of LSTM support. So we worked with, Gary's team to actually implement the operators that we needed to accelerate, for Lens use cases. And then with Brahim's team to figure out, okay, now how do we expose those operators in an API?
So we generalized it a bit, and then we baked into Android Q, so now it's available to everyone.
Yeah.
So it's not too specific that it's only useful to us.
Yeah.
Yeah, from our standpoint, this particular class is also one that's variable. It's like Node 2 developers that we've talked to previously, there's not really a generalized approach to implementation, so having guidance in this respect it's like a North Star to follow this path. So a lot of side benefits with that.
The point you're making about software being linear, and not a mind-blowing thing about AI, is that if you have personalized learning or any sort of on-device learning, the software is changing over time, right? Like it used to be that you ship bits and you test some piece of software, then you launch it, and it's largely static. It is what it is. Like the pixels don't move over time. Now, if you have something like Gboard, which has a bunch of actually personalization and federated learning, and we can talk about federated learning if you want, but it's changing over time. It's evolving. And just the release process of this software is actually completely different and very challenging. And it's still kind of something that we are trying to learn and perfect. And I know the team here thinks a lot about regression testing and integration testing and making sure. This is the boring part of this, but still, it's very different than actually just launching normal, traditional software.
Yeah, it's a whole new software development paradigm, period. It's like software 2.0. Everything changes eventually. The hardware and how it's processed, the way in which you program it, the whole thing top to bottom will be different than what we were doing 10 years ago, 5 years ago, maybe 2.
And I would say there's a deep interdependency now between the software layers and hardware, much more so than in the past. Before you can build an app, publish it onto an app store, and it largely works across all phones, right? To achieve what we're trying to do now, it requires a pretty deep partnership across the entire stack.
Yeah.
Very cool. Yeah, I mean, and we see this. I mean, everywhere. When you optimize for the hardware, things just cruise. Whether it's everything, a game, audio quality, everything. Is there anything else that has blown your guys' mind in AI recently?
Talk about federated learning. Federated learning is pretty cool.
What is it?
Federated learning.
Federated learning.
Gboard is federated learning, and what it means is essentially you can. So you create this is very I don't even understand it super well, so I'm gonna. This is diluted, but my interpretation
I'll jump
is
in and correct you.
Thank you. I think the way it works is you build kind of a 10% ready model in the cloud, a very basic model. Then you push that model to all your users. Let's assume you have 1 billion users, small app, and then you train locally. You use data on a device. On every device, you train a model that gets better and better and better. And then what you do, you ship the weights back to the cloud, just the weights on the model, so not the actual model.
Right.
And this is, okay, maybe it's going to get a little complicated.
No,
but
it might be worth explaining that too.
yeah, so the model is essentially a bunch of weights on different connections between the graph. Think of it as it's a graph of interconnected nodes, and then there's weights on each of those. And those weights are really what you train. You train to figure out is it a 40% likelihood to go here or 30% likelihood to go there? And it's just very, very, very simply. So those weights in themselves aren't user data. They're not. They're just they're just weights that are derived from that data. Mm-hmm. And so what you do with federated learning is you derive those weights on device, and then you aggregate the weights on the cloud to create a really high quality model. And what this means is you can actually train really great models without ever moving user data into the cloud. Entirely on device.
Cool.
And this is really emerging, and it's not and correct me if any of that was wrong. I'm
You know more than I do, actually.
I think that's how it works.
Yeah.
But it's an emerging field. I think it's going to make a huge difference in the future for AI, especially with privacy. I think it's going to be a good way. It's not just privacy. It's also that there's vast amounts of data that you just don't want to move to the cloud.
Correct.
That's right.
You can never move everything. You can never move every value of every sensor on, like, you just too much data. And also you probably don't want to do that.
Yeah.
Correct.
And this allows you to use that data that was previously completely like unattainable, to use it to build like way better models, and then actually, use those models for inference as you would otherwise.
Yeah, I'd say, today it's like develop a model in the cloud, train it in the cloud, miniaturize it, and then have it run on device.
Yeah.
But now we're just executing that model on device. The key difference for federated learning is you're actually training the model through on-device signals. So now you can, including all the benefits that Brahim mentioned, it also allows personalization now, right? So there's some amount of personalization that you can add to the models. Like this network understands you, right? Mm-hmm. It's not just a generic model that can, like recognize cats or plants or things like that.
Mm-hmm. So do you see people creating, like big companies like you guys creating models that way? Or do you also see smaller developers doing the same thing with that type of learning?
When I chat with the team, it seems like anyone can do this. I think it's one of those cases where it needs to get simpler. Like the TensorFlow team just recently released TensorFlow Federated. That's a step towards, they open source a bunch of tools. So I think they're definitely moving towards making this more approachable and easier for developers. One of our products is ML Kit, which is an SDK. And I want this to be one day where essentially, like, I just check a box and I say, either improve my model based on these data points on device, and it just does it. And I don't have to actually worry about anything. I think when you get to that stage, then I can see a lot of people do it. I think right now it is way more, it's more complicated.
ML Kit's actually just brilliant.
Oh, cool. Thank you.
Well, there's the democratization of all this, right? Going from PhD level, only a certain few, to now, you don't really have to be an expert software developer. The tools are all there. The models are there. The ability to integrate them into an application is there. It's not...
Sorry to interrupt. ML Kit is it's a software development kit for building apps with AI. Is that?
That's right.
Yeah,
That's a high-level view, yeah.
Bam.
I got something right today.
Yeah.
Awesome.
Yeah, it's pretty complete.
Cool.
Yeah.
And then how does it work with the Android NN API?
It uses it.
Okay.
So, I mean, it uses it wherever possible.
Okay.
It's one of those things where we are still evolving all products at the same time. So we're kind of, changing the wheels on the plane, or whatever that expression is, while we're flying and landing. So I think it's over time you'll get, everything will get better. Oh. But it is a nice, it's again towards our mission of democratizing ML, making it just not so special. Like, you don't need to have a PhD to use it. Right. It just works, and that's kind of what MLK is trying to fill that hole. We offer like primitives of ML, like simple things. We don't offer complete experiences, but we let you do things like face detection and
natural language processing, and
we like smart reply, like little things like that, where like you can then use them to build an experience as a developer.
Those are big things.
I mean,
little things like identifying a face. That's mind blowing. Yeah.
So we started back in Snapdragon 820, which was like 4 premium tier generations ago, and that's really not a long period of time. And back then, things like scene detection were a curiosity, not necessarily ones that, if you think about all that goes into scene detection, the ability to set the 3A in the camera is really the high value, right? The whole entire pipeline changes. It's not just a feature that sits on top of that in an app. And to think that we're now to the point where you have tools that are pretty complete, that really abstract everything and make it so simple for a developer to not have to worry about that, and then move on to the ideation around what that use case is that leverages it. Really where their time should be spent.
Exactly. That's our mission.
And this is what I'm observing. Is this correct? Traditional algorithms, like you're saying, like let's say in camera 3A, which is like autofocus, auto white balance, auto exposure, the basic things that in order to get like a good picture, you just need those basic things to work. Those traditional algorithms, things like that are being replaced by neural nets.
The entire camera pipeline will be just AI at some point in time in our, I think, relatively near future. You could do most of this in software with an accelerator. Some of it's still researchy, but the quality's gotten so much better. The access to data, the compute capabilities are all there. So it's just a matter of time.
Some of our team may disagree with that. Unless you consider computational photography AI as well. But computational photography is pretty awesome as well. And like some of definitely the camera team, we're still investing heavily there, obviously.
Wow.
It's a big area.
All right, guys, thanks again. This was awesome. I appreciate everybody coming in, and maybe we'll do it again.
Yeah. Thanks for having us.
Thanks, guys.
Awesome
Thanks very much.
Thanks for listening to the Qualcomm podcast. And if you haven't already subscribed to our podcast, you can do so via SoundCloud, Apple Podcasts, and Google Podcasts. For even more news on Qualcomm technology, check out our Facebook page and Twitter feed. And by the way, my friends from legal really want you to know that references to Qualcomm may be Qualcomm Incorporated, Qualcomm Technologies Inc., and/or its subsidiaries.